Hello. This is Conservation of Energy, Part 2. This is a continuation of the last lesson, Conservation of Energy. This is the question. I have a child whose mass is 14.8 kg. The child is sitting on a swing. The swing's mass is 1.3 kg. And a boy lifts the child and a swing by a height of 52.1 cm. Then let go. What is the speed at the bottom of swing? So let's draw a diagram. So this is the swing. The child and swing together. Mass total. The total mass is 14.8 plus 1.3 is 16.1 kg. That's the total mass. So 16.1 kg and 16.1 kg. Now child and swing, they both are lifted by a height of 52.1. This is what 52.1 means. So the height is 52.1. This is cm. So you let go. You lift the child and swing to this position and let go. What does let go mean? The let go means the velocity here is 0. Find the speed at bottom. Find the speed at this point. So I want to find the speed here. So how do I do it? I use conservation of energy. Look. At this position, the child and swing has no kinetic energy because V is 0. But they have a potential energy. Now, potential energy, you need to choose a reference level. So in this case, the easiest way to choose a reference level is the bottom level. Choose this level as 0 gravitational energy. So, child and swing both have a potential energy. At this position, no kinetic energy. And because my reference level is this line, therefore, when the child and swing is at the bottom, then there is no gravitational potential energy, and they only have kinetic energy. So this is a transformation of one form of energy to another form of energy. In other words, the potential energy here is entirely transformed to the kinetic energy here. Therefore, from conservation of energy principle, we have potential energy here, mgh, at this position, is entirely transformed into kinetic energy here. And do you see that the mass can be cancelled? So I cancel the mass. I multiply 2 to both sides. So I have 2 GH equals, multiply 2 on the right-hand side, I only have v squared. Now, I put in the numbers. G is 9.8. H is this, but I need to change it to meter, 0.521. 2GH equals V squared. So V is square root 2 times 9.8 times 0.521. Now you can use your calculator. As I mentioned in my last video, conservation of energy, which we can call it part 1, although I didn't write down the word part 1, but you can consider it as part 1. From that part, I recommend you do this kind of calculation. Use your calculator in one step. So you enter the 2, enter multiply, enter 9.8, enter multiply, enter 0.521, and press equal sign, which gives you the value of this. Then press the square root button. Square root of the answer, this part. Square root answer, you get the answer right away. So what is the answer? I did that, and the answer is, okay, the answer is, okay, I have it worked out. The calculator is so powerful, it gives you so many decimal points. So this is the calculator answer. But you do not need so many digits, so you round it up. And finally, you write down the units, meter per second. So this is how you do this problem using conservation of energy. All right, let's have a second example. I have a ball, and you drop the ball from a height of 10.5 meters. And when it hits the ground, there is a velocity of impact. So find the speed of impact, or find the magnitude of the velocity of impact. This means what is the velocity just before hitting the ground? Okay. I have a student, he says that when it hits the ground, the velocity is 0. That is so misleading. You find this is, you want to find the velocity before hitting the ground. Just before hitting the ground, there is a velocity. The velocity is not 0. Okay, how do you do that? You can do it in 2 ways. Let's first draw a picture. So you have a ball. The ball is dropped. The word drop means you are not throwing it down. You just let go. You just release the ball, so the velocity is 0. This is the ground, and the height is 10.5. 10.5. What is the velocity just before the ball hits the ground? What is the velocity here? How do we do it? You can do it in two ways. This is a kinematics problem. So you can use kinematics formula. So there are three. V final is equal to V initial plus acceleration time. The distance is the V initial times t plus 1/2 acceleration time squared. The third equation is V final squared equals V initial squared plus 2 times acceleration times the distance. Now remember, these three equations are vertical equations. They refer to the vertical motion. So this d is a vertical distance. Okay. All right. Since this ball is dropping down, I can choose down as positive. Choose down positive. If I choose down positive, the 10.5 is positive because this is a displacement. Displacement is going down. The ball is going down. So this is positive. The acceleration is 9.8 downward. If I choose downward positive, this 9.8 is positive. Now what is given? The initial velocity is given. So this initial velocity is 0 because it is dropped. The initial velocity is 0. I need to find the final velocity. Okay, so this I don't know. This I know. This is 9.8. I don't know t. I don't know v final. Actually, v final is what I want to find. In this, vertical displacement is given. Initial velocity is given. A is 9.8. I don't know t. But in this equation, t is the only unknown. So I can find t from this equation. Let's go to the third one. V final, I don't know. V initial, I know. Acceleration is 9.8. Distance is 10.5. This equation tells me V final. So I don't need this. I don't need the time because the question is asking the speed of impact. So I use the last equation to find this. So my answer is V final square is, this is 0. So I don't need to write 0 square. I just write 2, 9.8, and 10.5. So this is kinematics way. You use the three equations of motion. They are called equations of motion. So you can find the VF. I'm not going to write down the calculation here, because this is one way of doing it. So there is another way, because we are talking about conservation of energy part 2. So let's use conservation of energy. At this point, V is 0, therefore no kinetic energy. If I take this level as the 0 level for gravitational potential energy, this is a reference level, then at the beginning the ball has no kinetic energy, but it has potential energy. At this position, it has kinetic energy, but no potential energy, because this is my reference level. Therefore, the potential energy here is entirely transformed into kinetic energy. So I can use this. Using conservation of energy, I can write mgh. That's a potential energy here, is equal to, it's transformed into 1/2 mv squared. And this v is my final read. Again, you cancel the m. Multiply 2 to the right-hand side, and to the left-hand side. So I have 2gh equals V final square. Look, this is exactly this. So you see, kinematics way and conservation of energy, they give you the same equation. Therefore, the answer, of course, is the same. So if I do 2 times 9.8 times 10.5, just use a calculator in one step. You enter 2, you enter multiply, you enter 9.8, and then you enter multiply, and then you enter 10.5, and press equal sign, which gives you the value of this. But you want to square root that value, so you press square root button followed by answer. Then you get a VF. So what is my VF? I have my answer. I just copy it down. The VF is 15 decimal and you can round it. So that is your answer. So remember, I highly recommend you do everything, if possible. You do the calculation in one step using your calculator. The advantage of doing this in one step is that you have all the decimals from your calculator. And then finally, you round it up. You got it? Okay. So compare these two methods. So this seems longer, you see? And this is shorter. So remember, conservation of energy is a very powerful way of doing this kind of questions. Let's have another example. Now this example is this. You have a projectile. And the speed of projectile at the beginning is 3.2 meters per second. And the projectile is not thrown horizontally. It's not throwing horizontally. It's throwing at an angle of 33 degrees below horizontal. And the starting point is above ground. How far above the ground? 5.2 meters above the ground. What do you want to find? You want to find the speed of impact, which means you want to find the speed just before the projectile hits the ground. Okay, let's have a diagram. So 33 below horizontal. So this, suppose this line is a horizontal. So you throw it 33 below. Now, this is the ground. So you hit the ground. The height is 5.2 meters. The projectile is thrown this way, so it is this is the initial velocity, which is 3.2 meters per second, and the angle is 33 here. 33 degrees below the horizontal. So now the projectile goes like this, and it hits the ground. Just before hitting the ground, what is the velocity of impact? Use the principle of conservation of energy. Choose this level as the zero level for potential energy. The difference between this example And the last example is that this example, at the beginning, there is potential energy. See the height? There is also kinetic energy. See the velocity here? But at the end, there is no potential energy, only kinetic energy. So let's do conservation of energy. Potential energy plus kinetic energy equals potential energy plus kinetic energy equals kinetic energy. So this is V initial. This is V final. So this is V initial. This is V final. Okay. See again, the M can be cancelled. I don't want 1/2 here. I don't want it. I get rid of the 1/2 by multiplying this equation by 2. So 2 multiply this, 2GH. 2 multiply this, 1/2 is gone. So plus 1 V initial squared. 2 multiply this, V final squared. You see, I know G, I know H, I know initial velocity. I want to find V final velocity. It's very simple using principle of conservation of energy. So I put in the numbers. 2 times 9.8. H is 5.2 plus the initial is 3.2. And the final, I don't know. Again, using a calculator. In one step, you enter 2, enter multiply, enter 9.8, enter multiply, enter 5.2. Enter plus. Enter 3.2, enter square. You have a key on the calculator, it's called x square. So you press the x square, that gives you the square exponent square. So, and you press equal sign now. The equal sign gives you the value of this part. Once you have the value of this part, you want to square root it. So you press the square root button, followed by answer. And then you get VF. And I did this. Let me get my answer. So that's my answer from the calculator. Then I don't need so many digits, so I just round it. Okay, so I can write 10.6. Yeah, this is, I rounded 10.6. And so that's my answer. Now, how about using kinematics? Then it's more complicated in this case. Because in this case, you need vertical component and horizontal component. So look. The initial velocity is this, but this is the magnitude of the initial velocity. I need a vertical component and a horizontal component. So V initial y is 3.2 sine 33. This is downward. Huh? Do you see that? It is downward. So V initial x is 3.2 cosine 33 degree. This is which way? This is this way. Okay. Now, let us write the 3 kinematics formula. So V final is V initial plus acceleration t. Distance is V initial t plus 1/2 a t squared. And then V final square is equal to V initial square plus 2a distance. Let's see what is given. So these 3 equations are for the y component. Y only. Huh? These are vertical equations. So do I know this? Initial, final? No, I don't know that. But I know initial y component. I know that. I know acceleration. Oh, I need to choose whether up is positive or down is positive. Let's choose down positive. Okay. Down positive. If I choose down positive, this is positive 9.8. And this V initial is down, so it's positive. Positive, positive. T, I don't know. Distance, I know. This is down. The displacement is down, so it's positive. So I know it. I know it. I know initial. I don't know T. I know A. This equation can give me time, right? Now this, I don't know V final. I know V initial. I know V initial. Okay, so I know V initial. I know A. I know D. So from this equation, I can find V final. And I have one more equation. How about the x direction equation, horizontal equation? Horizontal equation is D horizontal. Yes, D horizontal is VT. V horizontal T. Let me see. Yeah, okay. This, I can find that. And so let's put, from this, I can find VF square already. So I write down VF square. So remember, this is a y component, VF y, V final y. V final y square is equal to V initial square. This is y. So what is V initial y? It's this, 3.2 sine 33. But I need to square it. And then plus 2 times 9.8 times 5.2. Okay. Let's see now, what else do I have? I have V final x. Now look, for the y direction equations of motion, I have acceleration. But in the x direction, there is no acceleration, right? In the x direction, the V initial horizontal is equal to the v final horizontal. The speed in x direction does not change because there is no acceleration in the x direction. So the v final x is equal to v initial x, which is here, v initial x. Right? Okay? Well, what is the v final magnitude? Look, at the final position, I have vertical component and horizontal component. So let's say this is the final position. So at the final position, I have vertical component, I have initial horizontal component. So this one, I use this label, final position x, and this is final velocity y. This is this, right? And what is this? This is this. I want this magnitude. So I want to combine these two components. I get this. This is my v final. So what is my v final? It's Pythagoras theorem. So v final square is v final y square plus v final x square. Now, I have this v final y square, which is this. Plus 2, 9.8. Okay, 9.8, 5.2. And what is my v final x square? V final x is v initial x and is this. So I need to square it. Oh, this is v final x. Okay. But I want v final x squared. So I square this and I square this. Now, oh, this is not right. Sorry, this is only the first part. This is only the v final y part. The v final x is this. So the v final, I was wrong. My writing is wrong. I need this plus this, right? Sorry, I got things mixed up. So it's v final y, which is this, plus v final x, which is this. Now I'm right. So I can, okay, let's write here because it's not enough space. So my v final square is, I write this as 3.2 square sine 33 degree square. Do you remember the square is written in between the sine and the angle, right? And plus 2, 9.8, 5.2, and plus this. So again, I write 3.2 square sine 33 degree square. Look here what happens. I have this plus this. And you see this is a common factor. I can factor it out. And then I have sine square 33 degree plus cosine square 33 degree and 2, 9.8, 5.2. Remember your trigonometry? Sine square plus cosine square is 1. Therefore, I have 3.2 squared plus 2 9.8 5.2. What did you see? What do you see here now? This. I go through all the kinematics, and I have this, but this is exactly this, you see? See that? So now you realize how powerful the conservation of energy is. It's so simple, it's short, and kinematics in this case, I mean, it's too long. The longer your work, the more likely you make mistakes. So it's not recommended. For this particular question, it's not recommended to do this way. You need to do conservation of energy. You got it? Thank you. This is the end of today's lecture. Please remember, if you have any questions, you can send me a message. I will answer to my best ability. So I welcome you to answer me, to ask me questions. So what is my number? 416-648-7783. Send message using this phone number, and I will do my best to answer your questions. Thank you for watching. Goodbye.